One of the most familiar structures in chemistry is benzene. It is known as one of the most stable and important compounds in organic chemistry. The benzene ring appears in many important molecules and reactions, from medicines like aspirin to materials such as polystyrene plastics, dyes, and industrial fuels and solvents. Many products are built around this structure. But this raises an interesting question. Why does benzene look like this? And how did chemists actually figure out its structure in the first place?
In the early days of organic chemistry, scientists knew benzene existed, but they were completely confused about its structure. It had the formula C6H6, which didn't fit the usual rules of bonding at the time. Most compounds followed clear patterns, but benzene didn't seem to behave normally. Then, in 1865, a chemist named Auguste Kekulé proposed a strange idea that benzene is made of a ring of 6 carbon atoms, with alternating single and double bonds. According to a famous story, Kekulé claimed he imagined the structure after dreaming of a snake biting its own tail, forming a ring. But later discoveries showed that benzene is even more unusual than that. The electrons inside the ring are not fixed in single and double bonds. They are shared across the entire structure. This special property is what makes benzene so stable, and it's known today as resonance.
Benzene is classified as an aromatic compound in organic chemistry. But what does aromatic actually mean? Back in the early days of chemistry, compounds found in natural sources like plant oils, resins, spices, and perfumes, many of which had distinct smells, were grouped together and called aromatic compounds. At that time, the term was loosely connected to their noticeable odor and origin in natural products. However, as chemical understanding advanced, scientists realized this classification was misleading. Benzene and related compounds were not special because of their smell, but because of a unique property in their electronic structure. So benzene is not just a simple ring of carbon atoms, it is a molecule with a unique stability caused by delocalized electrons spread across its structure. This is why it plays such an important role in many substances we use today, from medicines and plastics to fuels and industrial materials. Even now, benzene remains one of the clearest examples in chemistry of how structure alone can completely change the behavior of a molecule. That's all for today's video. Thanks for watching. If you learned something or have anything to add, feel free to comment below. Don't forget to like and subscribe. I'll see you in the next one.